All right, let's find the lengths of these segments. We need to find the length of segment AB. So from here to here means I'm going to need those ordered pairs. The ordered pair for A is 2, 1. The ordered pair for B is 6, 3. So I'm going to let point A be my x1, y1, and I'm going to let point B be my x2, y2. So to find the length of segment AB, we're going to need a big long square root sign. We do x2 minus x1, so 6 minus 2. Close those parentheses and square it. Then you do the same thing with y's, y2 minus y1, so 3 minus 1. Close the parentheses and square it. 6 minus 2 is 4, so we have 4 squared, plus 3 minus 1 is 2, so 2 squared. We have to square them, then add them, and then square root them. So I do the square root of 4 squared is 16, 2 squared is 4. So I have the square root of 20. So this side right over here is the square root of 20. If I want to know what that is and its decimal approximation, I can type it into my calculator. Square root of 20 is about 4.47. And then I need to find the length of segment BC. So I'm going to need ordered pairs again. I already have the ordered pair for B, but I don't have the ordered pair for C. Down here, that is 8, negative 1. I'm going to go ahead and let the 6, 3 also be my x2, y2 for this one, since I just already have it labeled that way. So 8, negative 1 would be my x1, y1 here. So I do x2, which is 6, minus x1, which is 8, square it. Then I do y2, which is 3, minus y1, which is negative 1. So I have 3 minus negative 1. Close my parentheses and square that. 6 minus 8, that's negative 2. So I have negative 2 squared. Plus, I do 3 minus negative 1. When you subtract a negative, that becomes a positive. So that's the same thing as 3 plus 1 squared. So that would be 4 squared. Negative 2 squared, remember, to square something means to multiply it by itself. So negative 2 times negative 2. Negative times a negative gives me a positive. So I have 4 plus 16. This one also comes out to be the square root of 20. So this side over here is the square root of 20, which is about 4.47. So what do we know about these two sides then? They're the same. They are congruent. So AB is congruent to BC. I'm going to go ahead and mark that on that picture. Segment AB is congruent to segment BC. All right, we need to find lengths now for AD and DC. I'm going to do AD in red. I already have the ordered pair for A, and I have it labeled as my x1, y1, so I'm going to go ahead and leave that. The point D right here has the ordered pair 5, 0. It is 5 to the right, but did not go up or down at all. So that's going to be my x2, y2. So from A to D, we do x2 minus x1, so 5 minus 2. Take it and square it. Plus y2 minus y1, 0 minus 1. Close my parentheses and square it. 5 minus 2 is 3, so I have 3 squared. And 0 minus 1 is negative 1, so negative 1 squared. 3 squared is 9. So underneath my radical I have 9. Negative 1 squared, negative 1 times itself, negative times negative gives me a positive, so that would be a positive 1. So this is the square root of 10. So this line segment right here is the square root of 10. I can get the decimal approximation for that by popping it into my calculator. Square root of 10 is about 3.16. And then we need to find the length from D to C. I already have C marked as my x1, y1, and D marked as my x2, y2, so I'm going to go ahead and just let that stay that way. So x2 minus x1, 5 minus 8 underneath my radical. Take that and square it. Plus y2 minus y1, 0 minus negative 1. Close my parentheses and square it. 5 minus 8 would be negative 3 squared. When I subtract negative 1, that becomes plus 1. 0 plus 1 is 1, so I have 1 squared. Negative 3 squared, negative 3 times itself, so negative 3 times another negative 3 would be a positive 9. 1 squared is 1, so this is also the square root of 10. Or about 3.16. Before we go on and do the slope, what kind of triangle are we looking at here? What kind of triangle is ABC? It's an isosceles triangle. How do you know? Two sides are congruent. AB and BC are congruent. AC is not congruent. So it's not an equilateral triangle because this half of it is 3.16, this half is 3.16. So this entire side is bigger than 6. These two sides are a little bit less than 4.5. So it's not going to be an equilateral triangle, but it is an isosceles triangle. So triangle ABC is an isosceles triangle. Something else I know about point D right here. If from A to D is 3.16 and from D to C is 3.16, what would we call this point D right here? On either side of it, it's the same length. So what would we call that? Midpoint. Point D is the midpoint. I'm going to write that down here. Point D is the midpoint of segment AC. All right, they asked me to find the slopes, and I haven't done that yet. So the slope of segment DB, this segment right here, I need an x1, y1, and an x2, y2. Well, I have both of these marked as x2, y2s from problems before. So I'm going to leave this one up here being my x2, y2. I just picked one, nothing special about it. And for the slope, I'm going to let this be my x1, y1. So to find the slope, we do y2 minus y1. y2 is 3 minus my y1, which is 0, over x2 minus x1. x2 is 6, x1 is 5. So I have 3 over 1. What does that simplify to? 3. So the slope of segment DB is 3. Now we're going to do the same thing, but for segment AC. I have these both marked as x1, y1, x1, y1. So I'm going to leave this one as my x1, y1 over here. Again, I'm just picking one. And for the slope, I'm going to let this be my x2, y2. So in my numerator, it's y2 minus y1. y2 is negative 1. Minus y1. y1 is 1. Over x2, that's going to be 8. Minus x1, which is 2. So in my numerator, I have negative 1 minus 1, which is negative 2. In the denominator, I have 8 minus 2, which is 6. Will that reduce at all? What goes into both 2 and 6? 2. So I can reduce top and bottom by 2. What would that give me then? Negative 1/3. So the slope of segment AC is negative 1/3. That's interesting. What do you notice about the slopes? They are perpendicular. The slopes are opposite reciprocals. That's why we know that they are perpendicular. One's positive, one's negative, and they are reciprocals of each other, 3 and 1/3. So point D is the midpoint. We just said that these two segments are perpendicular to each other. Does anybody remember what we call something that splits another object exactly in half? Bisector. So segment DB is the perpendicular bisector of segment AC. Remember, to bisect something means it cuts it exactly in half. All right. Nice work on the warm-up. We are going to switch into your notes, and then we'll be also in your book today. So please go ahead and pull both of those out. We're going to pick up in your notes where we left off on Friday, so bottom of the second piece of paper. We were talking about our isosceles triangle theorem. We talked about our isosceles triangle theorem and the isosceles triangle theorem converse. And I want to make sure that I'm really clear about this because there's been a little bit of confusion throughout the day. So my isosceles triangle theorem tells me that if I have a triangle where two of my sides are congruent, then the angles opposite those sides are congruent. Now, when I say that the angles opposite those sides are congruent, I mean these angles are congruent to each other. They're not congruent to the side. The side is going to have some measurement, either in units or in centimeters or in inches. My angles are always going to have measurements in degrees. And it's not going to be the same as the side. When I say they're congruent, I mean they're congruent to each other. But that doesn't necessarily mean I know exactly how big they are. I'm going to need some more information to figure out how big they are. My isosceles triangle theorem converse says if I have a triangle and I've got two angles that are the same as each other, they are congruent. then the sides that are opposite those angles would also have to be congruent to each other. It doesn't tell me how big those sides are, but it does tell me that I know that they are the same size as each other. We were just getting ready to start problem number 2 when we needed to end things on Friday. We're supposed to find x and y. Which one do you guys want to find first in this triangle? Yes. You want to find y first. Tell me why you picked y. We can use our exterior angles theorem to find y. I like it. Exterior angles theorem says that my exterior angle, how big's my exterior angle here? 104 degrees. This guy out here is my exterior angle. It is outside the triangle that I'm looking at. The exterior angle is going to be equal to the sum of the two remote interior angles, the two interior angles that my exterior angle does not touch. So that would be y and 28 degrees. These two here are the remote interior angles. So 140 degrees is equal to y plus 28 degrees. To figure out what y is, I'm going to subtract 28 from both sides. What is 140 minus 28? Or sorry, 104. I don't know why I have 140. I transposed my numbers. 104 minus 28. 70 how much? 76, thank you. And I apologize for transposing those numbers there, guys. 76 degrees is the size of angle y up here. So I'm going to go ahead and add that to my picture. 76 degrees. All right, so now I want to find x. Where is x in the picture? It's in all of the expressions representing the lengths of the sides. Do we know that all of the sides are the same length? No. In fact, I know for a fact that they can't all be the same length. How do I know that? They are, I'm pretty sure, going to all be acute angles. Are these two angles, the remote interior angles, the same? So there has to be at least one side that's not the same as the other two, bare minimum. So if my sides are different sizes, can I set them equal to each other? No. Only if they're congruent can I set them equal. Do we have a rule about what all the sides of a triangle have to add up to? Is that my sides? No. All the angles in a triangle have to add up to 180. But if I had two triangles like this, are those sides going to add up to be the same number? No, one of them is itty bitty. It's going to have really small measurements. The other one is much larger. I don't have any rules about what the sides of my triangle have to add up to. I just have a rule about my angles. My triangle sum theorem is about my angles. So I have to figure out whether I've got two sides that are the same or not. If I don't have any sides that are the same, I can't find x, and I'm stuck. And I'll just have to say cannot solve for x. How do I determine whether or not two sides are going to be the same size? Let's look at our triangle sum theorem, so my interior angles. What would I be looking for over here? What do I want to see? Yeah, I want this angle to either be 76 degrees or to be 28 degrees, because then I have an isosceles triangle, And then I've got some sides that are congruent to each other so that I can set them equal. How can I find this angle over here? Triangle sum theorem. There's another way I could find it. What's the other way? Linear pair theorem. I can use either one of those. I'm going to get the same answer either way. I'm going to go ahead and use linear pair theorem. If you want to use triangle sum theorem, please do so and check your answer against mine because we should get the exact same thing. So I do 180 degrees minus that 104, that exterior angle. What is 180 minus 104? 76 degrees. So this angle right here that makes a linear pair with 104 is 76 degrees. If I'd used my triangle sum theorem, I could have done whatever that angle was, plus 76 plus 28 equals 180. Does anybody happen to know what happens when you add 106 and 28 together? You get how much? Not 134, but 104. So I end up doing the exact same thing, 180 minus 104. And I get 76 either way. Okay, so I know that's 76 degrees. What does that tell me? We have an isosceles triangle. Two of my angles are the same size. That would be this 76 degree angle here and this 76 degree angle here. These angles are the same. So what would be my two sides that are the same? The right and the left. Let's look, we need to be across from those angles. Yeah, it's going to be bottom and the right-hand one.
I have my calculator, but I think it's out of batteries, maybe?
You'll need to get new batteries for it. But you can use this one for now. That table in the back, right back there. So bottom one, because we follow this angle across here, that takes me to 8x plus 18. So this is one of my congruent sides. Right down here. And the other 76 degree angle, the other one that is congruent, it's right here, and I follow that across here. So 6x minus 2 is the other expression for the side that is congruent. So to find x, we're going to set the congruent sides equal. So what am I setting equal? Six x minus 2 is equal to what? 8x minus 18. I'm going to subtract 6x from both sides so that I can group my x's together. So I have negative 2 equals what? Negative 2 equals 2x minus 18. Then I'm going to add 18 to both sides. And that gives me what? 16 equals 2x. Divide both sides by 2. And now I know that x is how big? X is 8. We could not have done that if this was a scalene triangle. The only reason we were able to find x on this is because we had an isosceles triangle, so that we knew that two sides had to be congruent to each other. That allowed me to set those expressions equal and to solve for x. We don't use 4x plus 4 unless we're trying to figure out how big that side is. It is not one of the congruent sides, so I didn't use it in my equation. All right, let's look at the problem at the bottom of the page before we go into your book. We've got a whole bunch of triangles in this picture, 3 triangles total. But I'm going to look at the 2 small triangles. So I'm going to outline this one in blue. This is one of the triangles that I'm looking at. What kind of triangle is that one that I just outlined in blue? Isosceles. How can you tell? 2 of the sides are congruent. The sides that are congruent here would be side BC and side DC. If those are my congruent sides, which angles would be my congruent angles? B and D. Be careful about that. There's 2 angles up at B, 3 actually if I'm looking at the big outside triangle, and there's 2 angles down at D, so we have to give these 3 letter names. But you're right, this angle right here, because it is across from this side, and this angle down here, because it is across from this side. Those would have to be my congruent angles. So the one up at the top, the one that you called angle B, that would be angle CBD. What would we call the angle down at the bottom that we said was our other congruent angle? BDC. Or, because I'm coming over here, I'm looking for BDC. I don't see that over here. Is there another way to name that angle? Backwards, angle CDB. You want to make sure that the vertex is the center letter. Vertex should be that center letter. All right, so how big is angle CDB? 54 degrees. So I can go and add that over here. Angle CDB is 54 degrees. What other angle are we supposed to find? We're supposed to find a bunch of other angles. Give me one other angle that we're supposed to find here. Angle C. What did they name that one? They named it BCD. Here's the C. That's my vertex. How are we going to find that angle? What about angle A? I don't necessarily know that it's congruent to angle A. I can use my triangle sum theorem to find that. So the measurement of angle BCD plus, what are the other 2 angles inside this blue triangle? And they're both how big? 54 degrees and 54 degrees. This one right up here, angle CBD. This one right down here, angle CDB. Both of them are 54. And I know that all the angles in a triangle add up to 180 degrees. So then I combine my two like terms together. What are my like terms here? 54 and 54. So we're going to add those together. Measurement of angle BCD plus, what's 54 plus 54? 108 equals 180. I'm going to subtract 108 from both sides. And so how big is angle BCD? 72 degrees. We have three more angles to find. Where's angle ADB? In the orange triangle. Which angle would it be? I'm going to number these just so we can reference them. Angle 1, angle 2, angle 3. ADB is which one of those? Angle 3. So this right here is angle ADB, because this is my vertex. Do we have enough information to find that angle right there? Yes, using what? Linear pair theorem. These two angles right here form a linear pair. So the measurement of angle ADB plus 54 degrees is equal to 180. So I subtract 54 degrees from both sides. And that means angle ADB is how big? 126 degrees. I'm going to write that down over here. 126 degrees. And I'm going to add that to my picture. (126 degrees). What kind of triangle is the orange triangle? Isosceles. How do you know? Two congruent sides. Right here, there's one congruence mark. And then down here on the bottom is another congruence mark. So I know that those two sides are the same size as each other. Which means what about the angles? There's two angles that are going to be the same as each other. Which angles will those be? BAD, this one right down here. And which one? ABD, this one up here. There's two ways that I knew it couldn't be that 126 degree angle that was one of my congruent ones. How did I know that there wasn't another angle that was 126 degrees? There's two different ways that I knew 126 degrees could not be one of my two congruent angles. Is 126 degrees acute, right, or obtuse? Obtuse, it's bigger than 90. How many obtuse angles can a triangle have? One. It can never have more than one obtuse angle. So because that was obtuse, I knew it couldn't be one of my two congruent ones. The other way I knew that, the sides that are congruent, if I follow them back, they both touch back here. Where the two congruent sides meet, that is not my congruent angle. That is not one of my congruent angles. If both sides that are congruent touch the angle, that's not one of your congruent angles. All right, we need to figure out how big those are. Do we have any idea how big angle A or angle ABD is? But I do know they're the same size as each other, right? You guys okay if we call them x? I don't know how big they are, but I know they have to be the same, so I'm going to let this one be x degrees. And I'm going to let this one up here be x degrees. And I can use my triangle sum theorem again now. For my triangle sum theorem, we have the measurement of angle ADB plus the measurement of angle ABD plus the measurement of angle BAD. That's equal to 180 degrees. Angle ADB is how big again? 126. So I have 126 degrees plus, do we know how big angle ABD is? No, so we're going to let x represent that. If I'm working on a problem and x is already being used somewhere, pick a different letter. Pick y if it's not being used. Pick z if it's not being used. What about angle BAD? Nope, don't know how big that is. We were letting x stand in for that. We know those two angles are the same exact size. I'm going to combine my like terms together, my x's. And I know I'm going to need to subtract 126 degrees from both sides, so I'll just go ahead and do that in the same step. X plus x would give me what? 2x. So I have 2x is equal to, what is 180 minus 126? 54. And then I divide both sides by 2. And I get that x is what? X is 27. So those two angles are both 27 degrees. Back here when I did 180 minus 126 and I got 54, I thought that was kind of interesting. Because I feel like there's a 54 degrees already on this picture somewhere. I want you to look at this 54 degrees. It's down here at the bottom with D as its vertex. Is that inside or outside my orange triangle? Outside. So 54 degrees is an exterior angle of that orange triangle. 54 degrees is equal to the sum of my two remote interior angles. Those were the two angles that we were looking for. So we could have done x plus x equals this outside angle, 54 degrees. We could have shortcutted that a little bit. Triangle sum theorem or exterior angles theorem could be used there. All right, we're going to put your paper notes away for now, and we're going to be in your book for the rest of our time, page 327. Page 327. The directions for this example, example number 2, say we're supposed to find the measurements of angle C and angle B. Why are they not asking me to find angle A? What'd you say? Tells us angle A is 70 degrees, so we already have that. This reminds me a lot of the warm-up that we just did. They went in and already found the length of side AB. That's what they did right here, using the distance formula just like we did. And they found that length to be the square root of 41 degrees. So this side over here is the square root of 41. And if I want to know about how big that is, I can pop that into my calculator. Square root of 41 is about 6.4. Then they did the same kind of thing over here for side AC. They found the length of side AC using the distance formula. And they said that that one was also the square root of 41. Or about 6.4. So what do we know about these two sides? They're equal to each other. So side AB and side AC are congruent. Well, now I want to know whether I'm looking at an equilateral triangle or an isosceles triangle. I know it's at least isosceles. It might be equilateral. So we need to find the length of the third side, which they did. They did it using distance formula, but because it's laying right on top of these grid lines, what's the other way I can find the length when it's laying right on top of those grid lines, either horizontally or vertically? We can just count them. So we go 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units. And that's what they said right down here. The only time I'm allowed to count is when it's not cutting across squares. If it is cutting diagonally across squares, I have to use distance formula. If it's laying perfectly on top of those grid lines, either perfectly horizontally or perfectly vertically, then I can just count. Is this an isosceles triangle or an equilateral triangle? Isosceles. And you know that because? It says it on the example, but how are you going to know it when you're doing your homework? Because it won't say it on your homework. How will you know that it's isosceles?
Because it looks like an isosceles.
Nope. Wrong answer. Two congruent sides. You cannot just go by what it looks like. You have to see that mathematically they are identical. Two sides that come out to be the exact same size. And the way you're going to find that when it's on a grid like this is by using your distance formula. What about a ruler? Nope. Have to use distance formula. So we have an isosceles triangle. Two congruent sides means what else? If it has two congruent sides, then it must have, what'd you say? Not necessarily. It's not guaranteed to have an obtuse angle, although we saw in the last problem it can have an obtuse angle. An isosceles triangle has two congruent sides, and so it has two congruent angles. Which angles would be my congruent angles here? The bottom ones. I'm going to take this side right here, follow it across to the angle it is across from. That would be this angle right here. That's C. This side right here is my other congruent side. We're going to follow that across the triangle to the other angle that would have to be congruent. So angles B and C are congruent. Those are the two angles that we're supposed to be finding. We're supposed to find the measurements for A and C, or for B and C, sorry. I do not like the way your book does this, so I'm going to do it my own way. I don't mind the way they set it up. They said angle A plus angle B plus angle C equals 180 degrees. That's totally fine. That's our triangle sum theorem. Do we know how big angle A is? How big is it? 70 degrees. Do we know how big angles B and C are? No, but we do know that they are congruent to each other. So what could I use in their place? I can use x in their place. X degrees and x degrees, because they have to be the same as each other, equals 180. We're going to combine our x's together because those are our like terms. I'm going to go ahead and subtract 70 from both sides while I'm there. When I combine my x's together, I get what? 2x. 180 minus 70 would be what? 110. I divide both sides by 2. And I get that x is how big? 55. X is 55 degrees. So what does that tell me? Angle C is 55 degrees and angle B is 55 degrees. Now we have answered the question. Let's look at the check problem right below this one. We're going to try to knock that out with our last 4 minutes. What are we supposed to find? Angle XYZ, so I start at X, I go up to Y, and then I go down to Z. So this angle right here is one of the ones that we're looking for. And we are also supposed to find YZX. So start at Y, go down to Z, and then follow that up to X. So this angle down here is the other one that we're supposed to be finding. Do I know what kind of triangle I have? Do I know whether it's scalene or isosceles or equilateral? Do I have any information about what kind of triangle this is? No. If it's scalene, I can't find these angles. I'll just have to say cannot find. If it's isosceles or equilateral, I can find these angles. How am I going to determine if it's isosceles or equilateral? How will I know if it's isosceles or equilateral? It can't be equilateral because all the angles would be the same. And what angle do we already know? We already know x, and it's 90 degrees. How many 90-degree angles can a triangle have? Only one, just like obtuse, can only have one. So it can't be equilateral. How will I determine if this is isosceles? We're going to find our missing angles. In order to find the missing angles, what do I need to do first? I need to figure out how big those sides are. If all 3 sides are different sizes, then all 3 angles are different sizes, and I can't find them. If 2 sides are the same length, then I'm going to be able to solve this because that means 2 angles would be the same size. Are there any of these sides that I can just count? Yep, from Y to Z. I can count that because it's right on top of the grid lines. This is 1, 2, 3, 4, 5, 6 units. How will I find XY and XZ? How are we going to find those lengths? Can I just count these? Then what do I have to do if I'm going to find those sizes? Use the distance formula. To find the length from X to Y, I'm going to need the ordered pairs. Let's go ahead and write down the ordered pairs, and then we'll save the rest of this to do during our Zoom tomorrow. So the ordered pair for X, I go backwards 3, so that would be -3, and then up 4. So -3, 4 is the ordered pair for X. What's the ordered pair for Y? 0, 7. Right, this is where we're going to pick up tomorrow. Before you guys pack everything away, things that I need to make sure you know, you need to take your book home with you tomorrow. We're going to finish this problem up, and then we're going to do 2 other problems that are in your book. That's going to be our Zoom tomorrow. With any remaining time that we have in the Zoom, I'll answer questions that you have about the homework. Your homework is due on Wednesday, which is the next time I see you in person. In order to get to our Zoom meeting tomorrow, you need to go to our class Canvas page. And you guys see these blue navigation tabs over here on the left? Towards the bottom, underneath where it says McGraw-Hill, there's a link that says Zoom. So from these left-hand navigation tabs in our Canvas course, you're going to click on Zoom, and then there will be a meeting there that'll ask you if you want to join it. You want to join that meeting, that'll send you into a waiting room. It does need to have your name there. Otherwise, I'm not going to know who's trying to join, and I won't allow you to enter. So please make sure it has your name for your screen name on Zoom. How do you get there again? Zoom link, same place you go for modules, only Zoom is further down. That will allow you to get in there. If you click on that Zoom link and you try to join the meeting that's there and it does not let you for whatever reason, please send me a message in Canvas. Try the Zoom link first, because I don't have time to be sending out like 37 million different Zoom links to people individually. But if you're having a problem with it and you've already tried the Zoom link here and you've tried to join the meeting and it won't let you, send me a message in Canvas and I'll send you a direct link to that Zoom meeting. All right? Okay, I will see you guys virtually tomorrow and in person on Wednesday.